Probabilities. Probabilities is the use of addition and multiplication law if A and B are events on the same space, and the event is the subject of the sample space. And the sample space of an experiment or a random trial is the set of all possible outcomes or results of that experiment. So in the first problem, letter A asks us that both hit a strike. What is the probability? What we are going to do is the probability of Mao hits and the probability of Fer hits. So we're going to multiply the probability that Mao hit it times the probability that Fer hit it. So it's going to be 2/7 times 1/3, and that is 2/21. Multiply it by 100 and it'll be 9.52%. Letter B asks us if none hit a strike. What we're going to do is that the probability that Mao misses and the probability that Fer misses. Those two, you're going to multiply them, in which is going to be 5/7 times 2/3, which will give us 10/21 times 100, it'll be 47.61%. Letter C tells us that Mao hits a strike, yet Fernanda doesn't. So what we're going to do is the probability of Mao hitting and the probability of Fer missing the hit. So it's going to be probability of Mao hits times the probability of Fer missing the hit. So it's going to be 2/7 times 2/3, and that'll give me 4/21, which multiplied by 100, it'll give us 19.04%, or they both miss. For this problem, we are going to use the addition law, because this problem is mutually exclusive since they cannot hit and miss at the same time. So what we're going to do is the probability of both hitting or the probability of both missing. Remember that or means union, and union means sum up. So we are going to do probability of both hitting plus the probability of both missing minus the probability of both hitting and both missing. And that'll give us 2/21 plus 10/21 minus 0, which is going to give us 7/21, which is simplified 4/7, multiplied by 100, it'll give us 54.14%. Last but not least is letter E. Either one of them hits a strike. So this problem tells us that at least one of them hits. So it's going to be like this. This problem is not mutually exclusive, so it will go like this. Probability of Mao hitting or the probability of Fer hitting, which is going to be the probability of Mao hitting times the probability of Fer hitting minus the probability of Mao hitting and Fer hitting. It is going to give us 2/7 plus 1/3 minus 2/21. It'll give us 18/21 minus 2 over 21, which it will be 11 over 21, which multiplied by 100 is 52.38%.
Permutations and combinations. A permutation is a number of different ways a certain number of items may be arranged in order from a larger number of items. This means that the order matters, and some examples is first place, second place, and third place, since the order does matter there. Combinations is the number of different ways a certain number of items may be selected as a group from a larger number of items. The order does not matter here, and a great example is to grab 3 volunteers, since there are no roles or titles involved. It's also very important to know what is a factorial. A factorial is a multiply of whole numbers from the chosen number down to 1, and the symbol is an exclamation mark. This problem can be solved by either permutations or combinations, but we will show both. As you can see, the formula for combinations can be arranged in many different ways. In this problem, we are trying to find all the choices available of how many different possible meals the restaurant offers for 1 course, 2 course, or 3 different courses. For combinations, you can say the problem as n, you choose r. For example, in the first course, we will be choosing out of 5 you choose 1 times 10 you choose at once times 4 choose out of 1. In the second course, it will be 5 you choose 2 times 10 you choose 2 times 4 you choose 2. And then the last course, the third, out of 5 you choose 3 times out of 10 you choose 3 times out of 4 you choose 3. Finally, you get the results of each course. To get to the final answer, you need to add all the previous answers, and that will be your final answer.